Okay, I'm going to get started. Welcome back. I hope everybody had a good Thanksgiving break and had safe travels. Did anybody else get stuck in that Livingston detour last night? Yeah, me too. It was pretty brutal. I was stuck there for like 2 hours. So welcome back. You've made it to the last week of the course, so good job. Wasn't too bad, right? Right, okay. So today's game plan is I'm going to first talk about just some important announcements and pretty much what's going to be going on for this week and next week as well. And after that, we're just going to finish up pandas. So that's kind of where we left off on Monday. If you remember, there wasn't many people here on Monday, so we're just going to be kind of reviewing pandas. We're going to be finishing that up today, and that's what we're going to be doing today. So tomorrow, Tuesday, right, there's a Lab 14 that you need to do, and all you need to do is you just need to take the course evaluation for this course. And that can be found on D2L, or if you just go to the Lab 14 assignment, you can click on any of these links, and once you click on it, it's going to ask you to sign in with your NetID. And so if I can show you kind of what mine looks like. Maybe. So it's going to bring up all your courses, and so like these are just all my courses, and so all you need to do is just start the evaluation and fill out. It's really not going to take much time at all. It should really only take 5 to 10 minutes, and it's really not too bad. And so all you have to do is to actually submit something on D2L, you have to submit some file, and so just submit any file, and in the comment box on D2L, be sure to say, yes, I completed the survey, and that's all you need to do. And so it could just be like a text file saying something. It could be like a screenshot of saying that you completed the survey. It could be a Python file that just says, I completed the survey. Could be anything. I don't know if your TA is going to look at it. I told my students last semester to just submit anything at all. Just submit a funny picture or your favorite YouTube video. And so last semester, I said that, and somebody submitted a 45-minute skateboarding montage video they made back in 2010. I don't know why I'm telling you this, but that's just my favorite thing I've seen as a TA. This guy just submitted their 45-minute skateboarding montage they made with their friends, and I don't know. That was just my kind of short story there. Be sure to leave some feedback for your TA as well. It kind of says in the lab outline to try to leave some feedback for your TA because it doesn't explicitly ask you for feedback about your TA, and so us TAs would greatly appreciate that. And then also your TAs should be there for the lab tomorrow as well as for the open lab, and so if you want to work on Program 6, which is also due this week, I'd recommend doing that. Wednesday's lecture, we're going to be just taking the practice practicum, okay? John Paxton's still not going to be here. I will be in here. I'm not printing out anything. The practice practicum is just found on the course webpage under Wednesday, and so what we're going to be doing is just going to be looking at this, and you're going to be taking it, okay? So that's all we're doing, and so I just say that because there's not going to be any lecture recording, there's not going to be any important information I'm going to be talking about. We're just going to come in here, and for 50 minutes you're just going to take the practice exam, just kind of get some practice. If you want to take the practice exam from your own house or in your dorm on your own time, that's fine. This 50 minutes is just there for you if you want to come in. If you don't want to come, that's fine. I wouldn't if I were you, just because you can sleep in a little bit. Also on Wednesday, Program 6 is due, right? It's due at 11:58, the normal time. I will mention that I do normally hold those help sessions for the programs. I unfortunately won't be holding one for Program 6 just because I simply don't have enough time. I'm I'm super busy this week. I'm a full-time student, and so, hopefully you understand, because I bet you guys probably have a lot going on this week too. I just don't really have the time to commit to helping out people for several hours. If you have any questions, you can always email me or your TA or John. I'll probably be peeking my head in there throughout Wednesday and see if anybody needs any help, but I just wanted to announce that in case anybody was planning on going to that. So get started on it now. I don't really think it's too bad. You guys should have all the tools you need to get started on. I know there's some people who've already submitted it. Friday, which is kind of the last kind of in-class lecture per se. John Paxton will be back in here on Friday, and he's just going to cover the answers from the practice practicum you guys are taking on Wednesday, and answer any other kind of remaining questions you guys might have. All this information I'm talking about is I'm just pulling this from the course website and from D2L announcements. On Sunday, December 8th, there is a optional review session for the final exam. That's on Sunday, December 8th, so a week from yesterday, from 3 o'clock to 4 o'clock in bar number 347, which is on the third floor of this building, obviously. It's going to be like a conference room. That's where it's going to be held. And be sure to come with questions, because he's not really going to have anything kind of planned, really. He might have an example planned, but be sure to come with questions if you plan on coming. And then on Monday, December 9th, which is a week from today, right, it's going to be the final exam, the final practicum, which is kind of scary to think about, that you only have 1 week until the final exam. The semester has gone by fast. So that's going to be 8 a.m. to 9:50 a.m., so it's going to be kind of like an hour earlier than when we normally start. It's going to be in this room, Barnard 103. I recommend please be there if this is your first semester in college, this is your first time taking a college exam, final exam. Please be there, because if you sleep through it or you miss it, it's going to be very difficult for you to recover from that, and it's going to be, you might not be able to make it up. So please set as many alarms as you need to be there on that morning. And John briefly talked about the final exam on that Monday, but just to kind of reiterate, the exam will cover material that was on previous exams, and so I'm kind of quoting kind of what John said on Monday. Is he said there's going to be like 4 questions, or no more than 4 questions, because we have an extra 50 minutes or extra hour about. And so like the first question would cover something from the first third of the class. The second question would cover something from the second third of the class, and then the third and the fourth question would be about something we've learned in this last third of the class in the past 4 or 5 weeks. And so maybe to kind of give you kind of like an idea, on last semester when I was taking for this class, the first question on the final had to do with like strings. The second question was about object-oriented programming. Third question was about NumPy arrays. And the fourth question was just kind of like making a horizontal bar chart using Matplotlib. So that's kind of give you a rough idea. Does anybody have any questions about the final exam or anything going on this week? You can totally ask John. If you have any specific questions about the final exam, I'd ask him on Friday, because he'll be there and he'll answer any questions you guys have. Any questions? Yeah?
Can we still use our old programs and such?
You can. It should be the exact same format as all the previous exams, where you can use your laptop, you can use your previous lab, you can use online documentation, all the course resources there, so it should be kind of the same as before, so yes. Yeah? Yes, so for Program 6, you can totally go into your lab tomorrow and just work on Program 6 if you want, or go to the open lab. I think that's a totally appropriate time to do that. Okay, that's all I have for announcements. I just wanted to kind of talk about that. And so today, I don't think we're going to take up the full 50 minutes for this course, or for this class period, because this example is a little bit short. And so this is kind of today's activity. We're going to be finishing up pandas, and we're going to be using, we're going to be working with this CSV file that we get from the Federal Deposit Insurance Corporation. And it's kind of like a list of all like the failed banks. This list includes the banks which have failed since October 1st, 2000, all the way up to present. And if you, to download this, you can go down here and click download and then drag it into your correct Python directory, which I've already done. And if I open this up, it's kind of a little hard to see, but we kind of just, all we have is like the name of the bank, the city where the bank is at, the state, the CERT, the CERT, I don't know what that is, but we have just like the institution that acquired the bank, when the bank actually closed, and like when the file was like updated with that information, I guess. So like this bank right here, the City National Bank of New Jersey, I'm sure you can't see that, but it was closed on 1-November-19, so just about a month ago, sadly. So let's go ahead and kind of copy and paste over our Python code that he gives us, and so this is what we have. And if we just like run this right now, let's kind of see what's kind of going on here. We get kind of two different plots here, and when you run this, you're going to get a warning message down here. We'll get to that in a little bit, so just ignore that for right now. So what this is, we just have two different plots here, and it kind of, on the x-axis, we have all the different years going from 2000 to 2019. For whatever reason, 2018 was never recorded in this file. And pretty much for each year, we have the amount of banks that closed for that year. So like for 2010 here, there's about 158 banks that closed that year. And both of these plots are pretty much showing the same data, but in this left plot, the red plot, our bars are kind of sorted in descending order from greatest to least, whereas the purple, the violet plot on the right shows it in kind of like chronological order, 2000, 2001, 2002, 2003, and so on and so forth. Okay? And just by looking at this, we can kind of see some really interesting things. So just by looking at this, we don't need to be an expert in pandas or computer science or history or economics. We can look at this graph and we can see that something happened in 2008, 2009, 2010, 2011. So does anybody know what kind of was going on in that time? Yeah. Yeah, we had like a recession, I think, right? And then our economy wasn't doing so well, and I think the housing market crashed, and that's kind of what happened. And so that kind of, all that kind of affected how the amount of banks that closed, right? And so it kind of makes sense. Just from looking at this graph, you can kind of see that. It's kind of cool because we don't need to be an expert in anything to kind of see that. Okay. So we're using pandas and matplotlib here still, very similar to what you guys did in lab 13 on that Tuesday before we left for break. And we kind of start off with the same thing. We use this read_CSV pandas method, and what that does is going to take that CSV file and pretty much turn it into a pandas data frame. So our data frame here is called failed_banks. And we can, if we just kind of want to see what this data frame looks like, we can say, let's print out failed banks, and right, this file is 560 lines long. And so I don't want to include every line, so maybe if I just want to print out just like the first two rows of the data frame, I can use like kind of a list slicing there. And so if we close this and we expand this and see a little bit bigger, we see we have two rows there. We have kind of like row 0 and row 1. And with row 0, we see we have that City National Bank of New Jersey, which was, let me scroll up. That was our first line in the file, right? So that's good. And we kind of have kind of like an ellipses here, kind of like a break there. And then it gives us the last column, which was the updated date, which was 7th November 2019. And so, maybe I want to see like everything in the data frame, because like these kind of, those 3 dots is kind of leaving out a bunch of important information about our banks. We're not actually able to see our closing dates when we print out our data frame. And I think this is something new with the newer version of Python or pandas. And I had to Google this last night. And so if we want to print out everything, all of our columns, and not just the first and the last columns, if I say, if I come up here and I say pd.set_option, so we're setting the option, and the option we're setting is the display.max columns, so how many columns we're displaying, and I'm setting it equal to none. So there's not a limit for how many columns will get printed. I'll just print out everything there is. And so to verify that, now we're actually getting everything. We're getting the inquiring institute, we're getting the closing date, and the updated date. And so it doesn't want to print everything out on one line, so it kind of does that / that tells you that it's kind of moving on to the next line down. And so here's the first line, and then it continues on down here. So the Bank of New Jersey closed on that 1st November down there. Okay? Okay. I'm going to leave that there. And then the next thing we do is we say failed banks, our data frame, and then we say in brackets closing year is equal to 0. What that's doing is it's pretty much making a brand new column in our data frame, and it's setting every single value in that column to be 0. And just to kind of show that, I'm just going to copy and paste this guy. I'll put him right down there, so we print out our data frame before and then after we add a column. And if we expand this, we see that when we print out the second time, we create a new column called closing year, and we just set every single spot there to be 0. Okay? That is all that line is doing, is kind of adding a new column, setting everything in there equal to 0. Any questions so far? Okay. And then what we're going to do is we actually need to, instead of 0, we actually want to give it the year that it closed. And the reason we're doing this is if we actually look at the column, or kind of like how this column is formatted, how the date's formatted, we give it like the date, the month, and then the last 2 digits of the year. So right there it just says 7-November-19. Ignore what Excel's doing up there. Excel's doing some fancy work up there. But what we want to do is we want to take that 19 and replace that 0 with 2019, so the full year, not just the last 2 digits. Because when we plotted it, we gave the full year. We didn't just give the last 2 digits. We didn't have just 00, 01, 02. We gave it the full year. So that's what we're going to be doing in this next part. So we do a for loop, a for I in range, and it's going to go through for however many banks we have in the file, right? So we have 560 banks, right? So I will first be 0, and then 1, and then 2, and then 3, all the way up to 559, right? Because it doesn't include that top boundary. So what we say is we create a new variable here called year, and we say year is equal to our data frame, failed_banks .loc. So what is .loc? So .loc, I believe, stands for locate, and if we just Google pandas.loc, try to find some documentation, come across this, and this is .loc. It accesses a group of rows and columns by labels or some Boolean array here. So we're able to kind of like query some data from our data frame by giving it some like label or some like coordinate almost in our data frame. And so if we take a look at kind of like an example here, so for example here we have a data frame, and our rows are like different kinds of snakes, I believe, and then our columns are like the max speed and then the shield. Don't know what that means, but we can see that if we do our data frame dot locate and we give it just Viper, it gives us the Viper's shield and the max speed there. But if I give it a specific row and column, it's going to give me that specific value that's located in just that spot at that specific kind of like X coordinate and Y coordinate in our data frame. Okay? And so if we take a look back to our code, we say dot locate and we give it kind of like a row and we give it a column, right? So I is our iteration variable, so that's going to be 0, 1, 2, 3, 4. And so that's going to be iterating through all of the individual rows in our file. But then we're always looking at the same column. We're always looking at the closing date. So what this is going to do is in the first iteration of this loop, we're going to row 0 and we're going to the closing date. So it's going to pull just that closing date, and it's going to be a string, right? Because we're reading it in from our data frame. We have words, we have letters, so it's going to be a string. And then our for loop's going to go to I is equal to 1, and so it's going to get that guy, and that guy, and that guy, and that guy, all the way for all 560 banks we have in our file, okay? Next thing we do is we say year, we convert it to be an integer, and then we say year, and we use some string slicing here, and we say -2 to nothing. And so if you kind of recall, with list slicing and, let's see, let me close this guy. So if I'm just working in my shell here and I have some string, and I set it equal to 16-April-2016. Okay? If I use lists or a string slicing, and if you remember, we kind of give it a pair of brackets and a colon. So like everything that goes on the left side of the colon is kind of like where in the string we want to start, and everything on the right side of the colon is like how far we want to go in our string before we tell it to stop. And so if I say, okay, let's start at the second character and let's go all the way up to the fourth character. And we see that we just get a -a. So remember that we start counting at 0. So this 1 was 0, 1, and here we started at 2. So we started at the dashed line, and then we're going to stop at 4. So we're going to print out A, and then we get to kind of like this the fourth spot, and remember that this top part is not inclusive, so it's not going to get printed out. So we're just going to get a -a there. And so if we take a look, kind of like what we did in this example, is we started at -2, and we went all the way through, and we see we just pulled just those last 2 digits there, right? And so what we're doing is we're starting at 2, like we're counting backwards, right? So we're counting backwards 2 spaces, and we're starting there, and we're just going to take the rest of the string with us. This is really nice because no matter how long our day is, we can have any month at all, and no matter what, we're always going to pull those last 2 characters from our year, right? We're always going to count backwards. We're going to start -1, -2, and we're going to get that 1, and we're just going to take the rest of the string, so we're just going to get the 16. Okay? And so that's what that's doing. Yeah? Does that make sense? And then we're adding 2,000 to it. That's how we're going to get our actual full year. And this we can add 2,000 because all our data is from 2000 to 2019. And so adding 2,000 will always work. If we had like data or banks, the data from the banks closed in like 1997 or 1998, that wouldn't work, right? Or else we get like 2098, 2097. And so we're adding 2,000 here because it works for us. Okay? And here, the next line is we do the dot locate again, and we give it the exact same information, and we set that spot, we set it equal to year. So we just kind of created. So we're going to take that 0 and we're going to replace it with the year. So we're going to replace 0 with 2019, 2004, 2006, 2010. Okay? So that's what this for loop is doing, is we're actually just filling the column we created with the correct information. Does anybody have any questions so far? Okay. Cool. And so now is we're actually going to start plotting this information. And so we create a figure here, and we say plt.figure, bank information. And if you remember what this does is plt.figure will change like that top bar. So up at the top bar of our window there, it says bank information. By default, it says figure 1, I believe. But we can change it to whatever we want, so we just change it to bank information. Okay, and the next thing we're do is we're going to do a plt.subplot. And I don't remember if we've looked at this yet, but we see that in a single figure, in a single window, we get 2 graphs, which I think we've seen before in matplotlib. I don't know if we've seen that in pandas though. And so what this is doing is the subplot is we're kind of going to create a certain amount of space for these 2 graphs to exist at. And this is kind of, the syntax for the subplot's a little bit weird, is we kind of give it a 121, and it's not obvious at first what this 121 means. And so what I'm going to do is let's just play around with this a little bit. So instead of 121, let's change this to 211, and let's change this guy down here to 212, and let's see what happens. We still get our 2 subplots, but now we see that they're stacked on each other, right? And they're no longer side by side. So it turns out that each of these numbers kind of has a meaning to it. So we kind of give it 3 kind of numbers here. And if I change this back to 121 and 122, so what we have is this first number that represents how many rows are going to be in our plots, or in our subplots, how many columns we're going to have in our subplots. And then this last number is okay, what number plot is this? Is it the first plot? Is it the second plot? Is it the third plot? It's kind of the ID of each plot, of where it comes in the order, right? So this first plot's going to be the first one plotted, the second one's going to be the second one plotted. And if we see this, we see that in our plot, we just have 1 row, right? We have 2 columns, right? We have 2 different plots and 2 different columns. And so this guy's going to be 121, and this guy's going to be 122. So this is kind of plot number 1, that's plot number 2. And just to kind of change it back to what we had before, 211 and 212, if we run it, we'll get that they're stacked on top of each other now. They're stacked on top of each other now, right? Because now we have 2 rows, but just 1 column. So they're all going to be in the same column, but they're in different rows still. And it doesn't look very good because it's all kind of smushed together, and you could certainly, play around with some of the spacing there. But I'm just going to change it back to what it was before. And one interesting thing is let's change that to a 3 and see what happens. And let's change this guy to 132 and let's see what happens. So here we still have 1 row, but we have 3 columns. It works okay even though we only have 2 plots, and it says, okay, fine, we have a 3rd spot for some 3rd plot, but since nothing is there, we're just going to leave it as white space. So we see we just have an empty 3rd spot there to put our 3rd plot even though nothing is there. It works just fine. And so what if we change this to 2? So what if our subplots have different dimensions? And I'm not confident of actually what's going to happen here. So we just get 1 plot. Interesting. So I guess we're only plotting just this second guy, I guess. So some weird things can happen if you aren't consistent with the number of dimensions you have for your subplots. I was playing around with this last night at like 3 a.m. and I was getting 2 different plots to work, and so you can play around with it. You can kind of experiment to kind of see the behavior of it, of kind of what happens when you change those numbers there. Okay, I'm going to change that back to what we had before. Cool. All right, and then next thing we do after subplots. Anybody have any questions about the subplot? It's kind of weird, but hopefully that kind of makes sense. You're kind of dividing it up into rows and columns, pretty much. All right, next thing we do is we set the X label and the Y label and title. We've seen that for the past couple weeks. That's just how we change our axes. And the next thing is we plot our data, right? And so we say failed banks, and then we say closing year dot value counts, and we're going to be plotting whatever this guy gives us, whatever value counts gives us. Okay, and so I don't think we've seen this before with the dot value underscore counts. This is a super nifty method. I think this is like a super helpful method you can use for program 6. And so if we Google pandas value underscore counts, and we take a look at the documentation, we see that it's going to return a series or just some like list containing the counts of all of the unique values that we give it. So we're pretty much like calculating just like the frequencies of how many times a certain unique value appears in the file. So to kind of put that into our example, we are kind of doing this values counts method on the closing year column, right? And so our closing year column had our 2019, 2018, 2016. And so what this is going to do is it's going to pretty much find the frequency of each year and just kind of show what this might look like. If I copy this guy and I come down here and I say, let's print pretty much what we did before right there. So right here, right? So what this is saying is in our data frame, we had 157 entries that had a closing year of 2010. In 2009, the values count determined that there was 140 banks that appeared with the closing year of 2009. So we're pretty much kind of controlling for our year, and we're pretty much finding the frequency of how many times that year appears in our data frame. Does that kind of make sense? Yeah.
You can also use the dot sum method as well. Like if you were to like use it for the whole entire file, it will sum each piece, I guess, and then pull that specific piece out.
I don't know if you could use sum specifically here, because I feel like from my understanding, is the dot sum will actually like add together all of the integer numbers, I feel like.
As opposed to
As like kind of like grouping together everything by that. That's my understanding. You might be able to play around with it. I'm not super confident with that answer. But that's what value counts does as well, and I think there's also a dot group underscore by, which does something very similar to this. And so, like when I'm thinking, if I was a student, it's like, okay, how could I use this dot value counts with like the video game CSV library? So that's just something to think about if you totally have no clue what to do on program 6. Okay. I think it's a really nifty kind of function here. So I'll get rid of that. And so we pretty much plot that series, and we say the kind is equal to bar, and we say the color is equal to red. So with this dot plot, that's coming from our pandas library and not our matplotlib. It's a little bit confusing. So if I Google the dot plot, we see that we can look at all the arguments we can give it, and so the kind is like what kind of graph we want to make, right? So here we're making a bar graph, and so we set the kind is equal to bar. But you can see that we can also make a line, a histogram, a box plot, a pie chart, a scatter plot. There's a lot of different things. And then as well, we have the color as well, which we can, which we've seen before. And so we say the color is equal to red, And then we do the same exact thing down here, except we say the color is equal to violet. But there's kind of a couple differences here. With the value counts, we didn't give it any arguments up there. But down here, we said sort is equal to false. And so, what is that doing? Well, we saw that in the first plot, everything was sorted from greatest to least, and in the second plot, it was not. So by default, the value underscore counts is actually going to sort everything for you from greatest to least. And we can overwrite that. If we don't want it sorted, we can just come in here, we can say sort is equal to false. Okay? Okay, and so let's take a look at that warning. This isn't really an error, but it's more of like a warning. It's kind of warning us, is like, hey, your code works. It's okay, but it's not great. What it's saying? It's saying if you're using the dot plot, you should not use it with positional arguments. You should only use keyword arguments. And so, like in the future, instead of saying series.plot and with bar, say kind is equal to bar. And it's giving us that error, or this warning, on this line right here. So another difference you might notice is here we say kind is equal to bar, but right here we just say bar. And it turns out this way is actually also okay for you to do dot plot. You don't have to explicitly say the argument you're giving it there, right? So like before I said kind is equal to bar, you don't need to do that, but it turns out that if you don't do that, the order of your arguments matters. So like before, and I think we've seen this before, is you can give your arguments in any order. You can say x is equal to this, color is equal to this, y is equal to this, the title is equal to this. You could give it in any order you want, but if you don't explicitly say the argument you're giving it, the order matters. And so what this is saying is like pandas is looking at this and say, okay, what is bar? Is bar is the first kind of argument passed in. It's at position 1 in our arguments list, and so it's going to look at whatever argument is hard-coded for like the first argument. It's going to say, okay, bar, they're actually referring it to the kind, so we know that kind is equal to bar, and then it turns out that if I just say violet right there, it's actually going to give us an error. It's going to give us an error because it's not expecting the violet argument to come second, and it's not expecting the color argument to come second when we call our dot plot. It's expecting something else, and so it gives us an error. And so the warning there is like, you should be using, you should be explicitly saying what the kind, or you should be explicitly saying like what the argument is. So color is equal to violet. Okay? And so if we fix that, we don't get the error anymore. So that's what that warning was talking about. It's just kind of giving you tips, maybe for future versions of, for pandas or with Python, it's just totally going to wipe any kind of positional arguments, and it's only going to allow your explicit arguments there. Okay? Any questions about what we've done so far with plotting it with the values counts or anything like that? I don't think it's not too bad. I think it's pretty interesting. How much time? Okay. So, maybe it's like we've seen our graph as just a bar graph, but what if I wanted to maybe make this into like a pie chart, right? So if we have our circle, what if like each wedge or each slice of that pie represented each individual year, so we could see like the percentage of how many banks closed per year, if that makes any sense. So if we wanted to take our information in our bar chart and pretty much just convert it to a pie chart, it's actually really easy. Is instead of the bar, maybe for our second or for our right plot, let's change it to a pie chart. Instead of saying kind is equal to bar, let's say kind is equal to pi. And if you kind of remember, with a dot plot, we could give it any, multiple different kinds. And so if we say pi, that's going to give us a pie chart. All right? And if we run this, we're going to get an error. We're going to get an error because, let's see, it's giving us a type error. And it's saying when we're using a pie chart, we can't, with pandas, we can't really give it a color argument. It's going to do the colors for us. And so it's like, oh, okay, so let's just get rid of the colors equal to violet and let's see what happens. Okay, and if we open that up, we can see that we get a pie chart now. We get a pretty cool looking one, and so we can verify this is correct, right? Because in 2010, that was the highest amount of banks closed relative to all the other years. We see that 2010 is our biggest slice, followed by 2009, then 2011, 2012, and it gets a little bit smushed together and doesn't look very pretty, but you see that, pandas will do the colors for us. I would say that doing a pie chart is a lot easier with matplotlib, which you'll be doing tomorrow for the practice practicum, just to kind of give you a little preview. You're making a pie chart with matplotlib rather than pandas. Because with pandas, there's a little bit less, it's a little more strict with what kind of arguments you can give and how you can customize it. So matplotlib makes it a lot easier. And we can totally say, is like, instead of pi, let's make it a line chart, or line graph, whatever it is. And it's going to make it a line chart. And we kind of see that it kind of had the same shape as before, as we kind of had a very quick kind of rise in number of failed banks in that year there. And you kind of get a weird x-axis there. It's kind of weird. Anyway, that's we can make it a line chart. We can make it many different kind of plots and visualizations. It's really cool. Okay. Anybody have any questions about what we did? Okay, that's all I have to talk about today. We're finishing up early. If you have any questions, let me know. Wednesday, the practice practicum, come if you want. Yeah, have a good Monday.